Let's go ahead and solve a couple logarithmic equations. So to get started here, we have our log on one side all by itself, got a number on the other side. So we're going to use the definition of a logarithmic function listed here in the middle in the red box to go from logarithmic form over to exponential form and then solve the resulting equation. So I like to start out by saying, what's my base going to be? All right, the base goes as the subscript below the log. So in our case, on the first one here, the base is going to be x. So let's start with x. Now it goes as the base over here in the exponential form. It's not going to be raised to whatever's on the inside. This kind of looks like x raised to the 64th power. Not what it means, but what it kind of looks like. So in exponential form, it's not going to be x raised to the 64th power. Instead, we use the 2 from the other side in this case and get x squared is going to equal 64. Hadn't used the 64, it goes on the other side based on the definition. All right, this equation shouldn't be that difficult to solve down. We have the one side is being squared, so I would probably go ahead and just apply a square root to both sides. Normally, we want to remember a positive and negative when we apply the square root to both sides of an equation. In this case, we're going to end up with x on the left-hand side. The square root of 64 works out to be 8. But remember, because our x was in the base, it was the base of this log, the base has to be greater than 0 and cannot equal 1. All right, well, we're not worried about it equaling 1, but if we use both a positive and negative 8, that's not going to work, right? Because a negative 8 would be less than 0, not greater than 0. So let's go ahead and get rid of our negative. The only solution in this one is going to be x equals positive 8. For the one on the right-hand side, let's start out the same way. We're going to go from logarithmic form to exponential form. So start with the 7. It's going to work as the base in the exponential form. Now it kind of looks like 7 raised to what's on the inside of the parentheses. Remember, this is not going to look the same, 7 raised to all that 5x plus 4. Instead, it's going to be 7 raised to the second power. The 5x plus 4, however, goes on the other side. All right, not too bad of an equation here. We end up with 7 squared is 7 times 7, which works out to be 49. We'll bring down the 5x plus 4 from the right-hand side. Now, this is a linear equation, right? X raised to the first power. So what I'm going to do next is go ahead and get all the variables are already on the right-hand side. Let's subtract 4 from both sides to move all the constants to the left-hand side. So positive 4 minus 4 makes 0 on that side. So 49 minus 4 makes 45. And we'll bring down that 5x from the right-hand side. And then to get x all by itself, to isolate it, we'll have to get rid of that 5. So let's go ahead and divide both sides by 5. 5 divided by 5 makes 1. We're ending up with x equals, a little simplifying down here, we can do 45 divided by 5 makes 9. And then one last step here, we may want to go back and just double check, make sure that x equals 9 is okay. So where I'd like to plug it back in here, we have 5 times 9 plus 4 makes 45 plus 4, works out to be 49. And what we're double checking for on that is everything on the inside of this log, when you replace the x back with whatever value we found for x, has to be positive. If that had worked out to be a negative value inside the log, that doesn't work with the domain of logarithmic functions, and that would be a problem. We'd have to throw out that solution and say no solutions on this one. But it does work, so that is our solution. Hope this helps out. Good luck with solving logarithmic equations.